Hello, in this video we're looking at MEI Further Pure 1, the January 2011 paper, question 7, which is on graphs and inequalities. This is a long question, so read it through carefully first. The first two parts are both right down, so those should be straightforward. It even tells us that there are two vertical asymptotes and one horizontal asymptote. For part 3, it says determine how the curve approaches the horizontal asymptote for large positive and large negative values of x. Then we've got to complete the sketch of the curve and solve an inequality. And notice that the inequality is only worth 2 marks, so clearly it's using the previous work. Use the graph to solve the inequality. Okay, write down the coordinates of the 2 points where the curve crosses the axes. First of all, if x equals 0, then y is equal to 5 over minus 5 times 8, which is minus 1/8. So one of the points is 0 minus 1/8. The other one will be when y equals 0. Y equals 0 when x plus 5 is 0, when the numerator is 0, which means that x is minus 5. So the other point is minus 5, 0. Now it said write down, so we could have just written down those answers, but it doesn't take very long to write a little bit of working down, and it does mean that when you come to check later, you can make sure you haven't done anything silly. Okay, for the vertical asymptotes, I probably don't need to write any working down. I can just write these down straight away. 2x minus 5 is 0, means that x is 5 over 2. And 3x plus 8 is 0, is x equals minus 8 over 3. For the horizontal asymptote, we need to think about what happens for large x. So for large x, y is approximately equal to x. Well, the plus 5 isn't going to make any difference if x is bigger, is really big. 2x times 3x. I'm just ignoring the numbers, and that works out to be 1 over 6x. So for large x, y is equal to roughly 1 over 6x, which of course tends towards 0 if x is very large. So the horizontal asymptote is y equals 0. In other words, the x-axis. Determine how the curve approaches the horizontal asymptote for large positive and large negative values. Okay, for large negative, so for large positive, x, y is going to be a positive number over a positive number multiplied by another positive number, which is a positive number. So as x tends towards positive infinity, y tends towards 0 from above because it is positive. For large negative x, y is going to be a negative number over a negative number times a negative number, which is a negative number. So as x tends towards minus infinity, y is going to be negative, so it's tending towards 0 from below. Alternatively, you can just plug a very large value of x into the formula and see whether it's positive or negative, and that's perfectly okay as long as you make it clear that that's what you've done. It's also a good idea, even though it doesn't ask you to check also the approaches to the asymptotes, the vertical asymptotes. 2 of those have already been done for you on the sketch. So we've only got 2 to look for in this question. We need to look at what happens as x approaches minus 8 over 3 from below. So if x is just a little bit lower than minus 8 over 3, then when we add 5 to it, I'm going to have a positive number on the top. When I double it and take away 5, I'm going to have a negative number. And when I times it by 3 and add 8, it is going to be a very small negative number, and that is positive. So y, we know, is heading off very large, but it's heading towards positive infinity. As x tends towards 5 over 2 from above, that's the other direction that's not already shown on the graph. So x is a little bit bigger than 5 over 2. I've got a positive number on the top. I double it and take away 5. It's a bit bigger than 5 over 2, so that's going to be positive as well. And 3x plus 8 is going to be positive. So I've got a positive number again. So y is again heading towards positive infinity. Now I can complete my sketch. So I'll label these points. That asymptote is at 5 over 2. This one is at minus 8 over 3. Crossing the axis there is minus 1/8. And we know that it for large positive x, it tends to the asymptote from above, so I can mark that in there. And as it approaches 5 over 2, it's heading off towards positive infinity, so it's heading up there, and so I can join those up. On the other side, again, it was heading towards positive infinity, but it was heading towards 0 from below, and if we go back to the first page, it crossed the y-axis at minus 5, 0. So we need to mark that in. So it goes down, then it comes up again, and that point there is minus 5. Then we've got to solve the inequality. When is my graph less than 0? Well, simply reading off the graph, x is less than 0 when it's less than minus 5, the far right hand end, and also that section in the middle, which is minus 8/3 less than x less than 5 over 2. This question was nice because it alerted you to danger points, but be thorough so that you find these yourself, checking all approaches from both directions. Let's look at how the mark scheme works for this question. For parts 1 and 2, it's basically 1 mark per answer, so a mark for that intersection, a mark for that one, a mark for that asymptote, a mark for this asymptote, and a mark for that asymptote. There's a special case, 1 mark, if you've just written down x equals minus 5 and y equals minus 1/8, rather than giving, as it asked, the coordinates of the 2 points. For part 3, there are 3 marks. There's 1 mark just for getting the 2 things correct, and there is a method mark for evidence of a valid method. So either an algebraic argument or saying that you've done calculations, for example, put in x equals 100. There are no marks for this, but omit it at your peril. And then for the graph, basically there's just 1 mark for transferring your information on the left hand side and another mark for transferring it on the right hand side. For the inequalities, there's just 1 mark there and 1 mark there, correct answer only in both cases. If you want to find videos of other questions on this unit or on other units, please visit the Further Mathematics Support Programme's website. Goodbye.